Welcome to the electrical machine lab. Today we are going to perform load test on single phase induction motor. The apparatus required to perform the practical is ammeter 0 to 210 10 ampere quantity 1, voltmeter 0 to 300 volt quantity 1, wattmeter 300 volt 10 ampere quantity 1, tachometer digital type quantity 1, and the connecting wires of 2.5 square mm as required. This is a simple circuit diagram to perform the load test on induction motor. This is the running winding of the induction motor which are connected in parallel to the supply, phase and neutral, and this is starting winding of the induction motor which are connected in series with the starting capacitor and centrifugal switch, and the running capacitor is also connected in parallel to the supply, and voltmeter are connected in parallel, ammeter are connected in series, wattmeter are connected in series and parallel to the supply. And for load test, one mechanical arrangement for the loading purpose are mechanically coupled to the induction motor. Procedure: connect the circuit as shown in the diagram. Switch on the AC power supply. Press start push button of dual starter to start AC motor. Note down motor voltage, current, watt, speed and load on balance W1 and W2. Using the hand wheel of the brake drum arrangement, load the motor in step from no load to rated current or torque. Rated torque का formula है, rated torque is equal to W1 minus W2 multiplied by A, where A is the brake drum constant, that is equal to the radius of the pulley in meter multiplied by 9.81 the gravitational force. Point number 6, at each steps repeat step 4. Number 7, calculate the output power by the formula 2 pi nt, and number 8, calculate the efficiency, that is equal to output divided by input. This is the observation table. We will note down the line voltage, line current, input power, load W1, load W2. This all we will note down from the meters, and this is the calculated value torque. We will calculate by the formula W1 minus W2 into A. Speed we will get from the tachometer, and this output power 2 pi nt divided by 60 we will calculate by the formula, and efficiency output divided by input we will calculate by the formula. In addition to this, we will also calculate the percentage of slip also. Before starting the connection, we will once again see the circuit diagram. This is the AC supply, single phase 230 volt. We are giving to the dual starter. The output of the starter is connected to the induction motor via voltmeter, which are connected in parallel, wattmeter which are connected in series and parallel, ammeter which are connected in series, and this is the induction motor. The running winding are connected in parallel to the supply. Running capacitor are also connected to the parallel supply of the induction motor, and starting winding, starting capacitor and centrifugal switch which are overall connected in series, and the combined side of these are connected in parallel to the supply, and this is the rotor part of the induction motor. And this is the mechanical coupling. The induction motor is mechanically coupled to the brake drum arrangement, the load arrangement. Okay, and here is a two weight machine where we will note down the weight W1 and W2. We can also call it S1 and S2. And the machine on which we are going to perform the practical is the output power 1 HP, rated power, rated speed 1420 RPM, rated current 6 ampere, and rated voltage 230. So this is our panel on which we will perform the practical. This is the panel. Here we will get the AC supply, phase and neutral. Yes, this is the supply. And here is the starter, green button, this starter, start button, and red button, stop button is of the dual starter. In this panel, the dual starter are inbuilt in the panel. Starter are inbuilt in the panel. And this is, in this panel, there is a wattmeter, digital wattmeter, and its terminal, voltmeter and its terminal, ammeter and its terminal. Now we will see the terminal box of the motor. This is our terminal box of the induction motor, and this is the running winding. And after that, this is the running capacitor. This is the running capacitor. And this is the starting winding. This is starting winding. And this is the starting capacitor. And this is the starting capacitor. And this is the centrifugal switch. This. And this is our rotor. You can see it clearly. This is the rotor of the motor machine. Now we will see the motor. You can come here, and you can. This is the motor on which we are going to perform the practical. This is a 2 capacitor motor. Capacitor start, capacitor run motor, capacitor start and capacitor run. And is the terminal box of the motor. You can see here. This is the terminal box of the motor. This 2 red terminal is the running winding terminal, and this yellow terminal is starting winding terminal, and this 2 black terminal is the centrifugal switch, starting capacitor, terminal. And this is the terminal box of our motor. You can see here clearly. Motor is of 1 HP, rated power. Rated voltage 230 and current is 6 ampere rated current, and rated speed is 1420. This is our motor specification. You can see it clearly. Induction motor. On this motor we will perform the practical. And you can see this is the brake drum arrangement, mechanical arrangement, brake drum arrangement. With the help of this we will put the load on the motor. This is the weight machine. Vajan kata. This is a weight machine 2, W1 and W2. We will put the weight on the machine with the help of this hand wheel. If we move this clockwise, there will be the load on the motor, and if we move it anti-clockwise, the motor will become free from the load. And this is the brake drum arrangement belt. You can see here, this is the belt, brake drum arrangement belt, and this is the drum. This is the drum. When the drum get hot during the practical, we will pour here water for the cooling purpose. यहाँ पर हम पानी डालेंगे मोटर को ठंडा करने के लिए. Now we will start the connection. We will connect the phase wire to the wattmeter M terminal. Wattmeter M terminal. Now we will connect wattmeter L terminal to the ammeter. Ammeter input terminal. Now we will connect ammeter to the running winding of the motor. Now we will connect the neutral of the supply to the wattmeter V terminal. And now another neutral, we will connect this neutral to the running winding another terminal. Now we will short MC terminal of wattmeter, M terminal of wattmeter and C terminal of wattmeter to the C terminal of the wattmeter. So MC is short now. Now we will connect RW1 to running capacitor of the motor and running winding next terminal RW2 to running capacitor terminal, and the centrifugal switch and starting capacitor are internally connected. Similarly, starting winding is also internally connected, and here the circuit is open. We will close it with the help of the wire. We will close this. The circuit is open here. So now the connection is complete. You can see the connection is complete. Now only we have to connect the voltmeter. Now we will connect the voltmeter parallel across the supply, and we will connect this wire to the parallel to the supply. Voltmeter wire we are connected in parallel to the supply. So now connection is completely ready, and before starting the motor we have to take one precaution. That precaution is that motor should be load free. Motor should be load free. So you can see our motor is load free. There is no load on motor. Motor is free, you can see. If motor is not free, then the weight will not be zero. This weight machine should show the zero reading when the motor is load free, and this hand wheel should be free for keeping the motor load free. Now we will switch on the supply. Supply switch on. Now we will start the motor by pressing the green button, start button. So motor is now running now. You can see motor is running. You can see here the motor is running at no load. Motor is running at no load. Now we will note down all the reading: wattmeter, voltmeter, ammeter reading in the observation table for the no load test. And now we will also note down the speed of the motor at no load. So you can see the speed is 14994. We will note down all this reading for the no load in the observation table. This is our reading for the no load. V voltage 230 volt, I current 2.8 ampere, input power 251 V into I. S1, thus in the motor is no load, so S1 is 0, and S2 is also 0 because we have not put any load, and speed is 1496 at no load. Now we will put the load on the machine. 4 ampere means half load, 5 ampere means quarter load, 3/4 load, and 6 ampere means full load. We will take the 3 reading at quarter load, at half load, and at 3/4 load, and at full load. 4 ampere, 5 ampere and 6 ampere. Now we are going to put the load on machine with the help of the hand wheel. You have to move this hand wheel clockwise direction. Once you move the hand wheel, the belt will get tight, and we will take the reading up to 4 ampere. We will increase the current to the 4 ampere means half load. Now it is 3.5 ampere, 3.6, 3.7, 8, 9, 4 ampere. Now it is 4 ampere. For this reading, we will note down the wattmeter reading also and ammeter reading also. Wattmeter reading and voltmeter reading for this current. Similarly, we will take the another reading for 5 ampere. Now it is 4.12, 4.3, 4.5, 4.6, 4.7, 5 ampere. For this 5 ampere, we will note down the ammeter reading, voltmeter reading, and also the wattmeter reading. Now motor is too hot, the drum, so we will pour the water for the cooling purpose in this drum. Okay, 100 ml water is sufficient. Now we will take the full reading to the 6 ampere. Now it is 5.5, 5.6, 5.7, 6 ampere. And for this 6 ampere, we will note down voltage and wattmeter reading in our observation table. Now for 4 ampere, we have forgot to take the weight machine load. So for the 4 ampere, this is the weight for the 4 ampere S1 2 kg, and H2 4.5 kg, 5 kg. And for 5 ampere, the weight is 2 kg S1 and here is 8 kg. And for 6 ampere, the weight is S1 S2 weight is, you can see here, S1 is 2 kg and S2 is 9.5 kg. 9.5 kg. So our practical is performed. We will free the motor from the load with the help of this hand wheel. Weight will come to the zero. When you free the motor from the load, weight will come to the zero. Then we will switch off the motor by the red button and then we will switch off the MCB. Now we have noted down all the reading. For 4 ampere, see, reading is this, and for 5 ampere the reading is this, and for 6 ampere the reading is this. You can see it clearly. Then we will find output power with the help of the formula, efficiency with the help of the formula, power factor and percentage of slip. And after calculating, we will note down all the reading in the observation table. Output power, efficiency, power factor and percentage of slip. For the different load condition, output power, efficiency, power factor, slip. Output power, efficiency, power factor, percentage slip. Then output power, efficiency, power factor and slip. And this is the calculation for every reading. For the first reading, we are calculating torque by this formula, output power by this formula, efficiency by this formula and power factor by this formula and slip by this formula. Formula: torque is equal to S1 minus S2 bracket 9.81 into R. And output power is 2 pi Nt divided by 60. And efficiency is equal to output power divided by input power multiplied by 100. Power factor is W divided by VL into IL. And slip is Ns minus Ns divided by Ns. Precaution: motor should start at no load. The supply should not switch off before the motor is unloaded. While running on load, the drum should be cooled by the cool method. Then we will draw the graph torque versus slip, percentage of slip. Another graph of output power on x-axis versus torque. These two graphs we have to draw. Thus, we have performed load tests on single phase induction motor and drawn the performance characteristics of the induction motor. Thank you very much.